Alright guys, today we're going to talk about how to solve problems using elimination, similar to last class period, but we're going to take it a step further. So we're going to start with number 1, and it says use elimination to solve each system of equations. So first I want to check if my x's are on top of my x's, my y's on top of y's, my equal signs on top of equal signs, and my constants on top of my constants. Now, to be able to eliminate, you have to have one variable with the same coefficient and different signs. So if I look at my x variable, my x has a coefficient of 1 and a coefficient of 5, so those are not the same coefficient. That's not going to help me. If I look at my y variable, my y's have different signs, but their coefficients still are a 1 and a 2, so they're not going to cancel out if I add them together. When this happens, we need to be able to manipulate one of the two equations in order to make them eliminate. So I'm going to choose one of the variables to work with first. First of all, I think that the y's would be easier to work with because we have already different signs, and you just have to see if you are easily able to turn one of the coefficients into the other by using multiplication. So if I were to look at this, thinking about multiplication, could I easily turn a 1 into a 2? Yes, I could. I could multiply it by 2. So I'm going to multiply this top equation by 2, and my new equation is going to be 2x plus 2y equals negative 18. Then I can bring my bottom equation straight over. 5x minus 2y equals 32. Now I can add my two equations together and see what I get. So the 2y's cancel out. 2x and 5x leaves me with 7x. And then negative 18 plus 32 leaves me with 14. Next, to solve, I want to divide each side by 7. So if I divide my left side by 7, I'm left with x, and my right side by 7, I'm left with 2. Finally, I have to substitute 2 back into one of my two original equations to solve for y. So I'm going to substitute it back into the top equation. So we draw an arrow to exactly where we're substituting it in. And I write down my new equation. So I'm going to have 2 plus y equals negative 9. I don't know what I'm doing. Negative 9. Then to solve for y, I'm going to subtract 2 from each side. So if I subtract 2 from my left side, I'm left with y. If I subtract 2 from my right side, I'm left with negative 11. Finally, I write my answer as an ordered pair, x comma y. So my answer is going to be 2 comma negative 11. Alright, so that was just a nice refresher from what we did last class period. Let's go over to number 3 and talk about what we would do for this guy. So on this guy, I have my x's on top of my x's, my y's on top of my y's, my equal signs on top of my equal signs, and my constants on top of my constants. Now if you'll notice, none of these variables have the same coefficient. So I have a 5 and a 3 and a 3 and a 5. None of them have different signs. These are both positive, these are both positive. Now, I'm going to try what I did on number 1. I'm going to look to see if I can use multiplication to turn one of these coefficients into the other. So for example, let's choose the x's. Using multiplication, I cannot easily turn a 5 into a 3, because a 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. I don't get a result of 3. Now using multiplication, I cannot easily turn a 3 into a 5, because 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. I don't get 5 as a result. So using multiplication, I cannot turn one of these guys into the other. The same thing goes with y, because we also have the same coefficients there. So to be able to solve this, we actually have to manipulate both of our equations and get both of our coefficients to equal the same number. So I'm going to just choose a variable first. I'm going to work with my x's. To be able to figure out what number to turn those x's into, I need to think about what's the least common multiple. So let's start with 5. If I were to list out my multiples of 5, I have 5, 10, 15, 20, 25, and I could keep going on and on. Now I'm going to list out the multiples of 3. So 3, 6, 9, 12, 15, and I could keep going on. The least common multiple is the smallest number that both of them could be, which is 15. That means my goal is to turn each one of these terms into a 15, which means I want to multiply my top equation by 3, because to turn a 5 into a 15, I need to multiply it by 3. And I want to multiply my bottom equation by a 5, because to turn a 3 into a 15, I have to multiply it by 5. Now, just getting them to have the same coefficient isn't quite enough. We also have to get them to have different signs. So that means I'm going to choose one of these guys, and I'm going to make sure that it's negative. So I'm just going to put a negative sign on that top one. Now I can distribute and get my two new equations. So negative 3 times 5x is negative 15x. Negative 3 times 3y is negative 9y. Negative 3 times negative 10 is a positive 30. Now in my denominator, not my denominator, in my bottom equation, 5 times 3x is 15x. 5 times 5y is 25y. And 5 times negative 6 gives me negative 30. Now if I look at my two brand new equations, I do have a variable that has the same coefficient and different signs, so they'll cancel out. So let's add them together. 15 and negative 15 cancel out. Negative 9 plus 25 should give me 16y. And then 30 and negative 30 cancel out and give me 0. Now at this point, make sure you understand, this does not mean no solution. We still have a variable here, and to solve, I can divide each side by 16. So 0 divided by 16 gives me 0, and y equals 0. And that's okay. 0 is a number. We don't discriminate. Now, I want to take this 0 and I want to substitute it back into one of my two original equations. Doesn't matter which one, whichever one you feel is easiest. I'm just going to substitute it down here into the bottom equation. That means my new equation is going to read 3x plus 5 times 0 equals negative 6. Well, 5 times 0 is 0, which is not going to help me in any way at all. So I'm just going to say that it goes to 0 and it completely goes away, which leaves me with 3x equals negative 6. Then I can divide each side by 3, and x is going to equal negative 2. So my result here is negative 2, 0. Okay, let's try it again on number 4. If I look at number 4, everything's lined up good to go, but nothing's going to eliminate. So I'm going to start by looking at my x values. Using multiplication, I can't really turn a 2 into a 3 or a 3 into a 2. So if I look at my y values using multiplication, again, I can't easily turn a 3 into a 4 or a 4 into a 3. So I have to manipulate both equations, which means I have to start by choosing which variable I want to eliminate. It doesn't matter which variable you choose. If you were to choose the x's, you would have to find their common multiple and multiply it out. If you were to choose the y's, you would have to multiply their common multiple and multiply it out. However, what's important is we need to look at the signs. If you look at the x terms, their signs are the same, so we would have to do a little bit more work on that by multiplying one of them by a negative. If I look at my y terms, one is positive and one is negative, which means that those would easily cancel out. So I want to work with my y's. Now I need to think what the least common multiple of 3 and 4 is, and I can easily do that by multiplying them together. 3 times 4 is 12. So that means I need to turn this guy into a 12, and I need to turn this guy into a 12. So I'm going to start with my top equation. To turn a 3 into a 12, I need to multiply the whole equation by 4. And on the bottom equation, to turn a 4 into a 12, I need to multiply the whole equation by 3. Now just a reminder, these signs are already different, so I don't have to worry about signs over here. Now when I do this, 4 times 2x is going to give me an 8x. 4 times 3y is going to give me a 12y. Finally, 4 times 14 gives me 56, and it's okay to use your calculator in that case. Now in my bottom equation, I'm going to take 3 times 3x, which gives me 9x, and 3 times negative 4y, which gives me a negative 12y. Finally, 3 times 4 gives me 12. Now I can add my two equations together and see what I'm left with. 8x and 9x is 17x. My y's cancel out, and 56 plus 12 gives me 68. Now if we divide each side by 17, x is going to equal 4. Finally, I need to take this 4 and substitute it back into one of my two original equations to get a result. I'm going to substitute it back into my top equation on this one. So when I do that, I'm going to have 2 times 4 plus 3y equals 14. 2 times 4 is 8, so I'm going to have 8 plus 3y equals 14. I can subtract 8 from each side, and that's going to leave me with 3y over here, and 14 minus 8 is 6. So if 3y equals 6, that means y equals 2, and my final answer is 4, 2. Alright, we're going to skip number 5, and we're going to go down to number 6. On number 6, I have everything lined up, but as you can see, nothing's going to cancel out at this point. So again, I'm going to start by seeing if I can turn one of the numbers into the other. If I start with the x's, using multiplication, can I easily turn a 2 into an 8? I can. I can multiply that guy by 4. But remember, we want them to have different signs, so I'm going to multiply it by a negative 4. Negative 4 times 2x gives me a negative 8x. Negative 4 times negative y gives me a positive 4y. And negative 4 times negative 1 gives me a positive 4. Now bring your bottom equation straight over. 8x minus 4y equals negative 4. So this is a nice reminder that we don't always have to multiply both equations. Sometimes we only have to multiply the top equation or the bottom equation, and it'll work. So let's see what happens when I add them together. The x's cancel out, and 4 and negative 4 for the y's also makes that cancel out and gives me a 0 on the left side. On the right side, I have a 4 and a negative 4. Those also cancel out and leave me with 0. So just a reminder, when you're all out of variables, you need to ask yourself a very special question. Is this a true statement? Does 0 really equal 0? It does, so that means we have infinite solutions. I-N-F-I-N-I-T-E, solutions. Okay, next we're going to go to number 7. On number 7, I have x's on top of x's, y's on top of y's, equal signs on top of equal signs, and constants on top of constants. So if I look right now, I cannot, using multiplication, turn a 21 into a 6. I also can't turn a 6 into a 21 because it's 6, 12, 18, 24. 6 can't turn into a 21. I also can't turn a 7 into a 2 or a 2 into a 7. That means I have to multiply both equations. So let's choose a variable and go from there. I think I want to use the y's in this case because 7 and 2 are much smaller and easier to deal with than 6 and 21. So I need to think here. The least common multiple between 2 and 7 is 14. So I want to turn this 7 into a 14 by multiplying it by 2. And I want to multiply this 2 into a 14 by multiplying it by 7. Now just a reminder, they have to have different signs. So just choose one of your equations, top or bottom, and tack a negative sign onto it. I'm going to choose the top one. Well, if it lets me. There we go. Now, when I distribute, a negative 2 times a positive 21x is going to give me negative 42x. A negative 2 times a positive 7 gives me a negative 14y. And a negative 2 times a negative 35 is going to give me a positive 70. Now, if I distribute the 7 in my lower equation, 7 times 6x gives me 42x. 7 times 2y gives me 14y, and 7 times 10 gives me 70. Now let's add these two equations together and see what I get. For my x's, I have a negative 42x and a positive 42x. Well, those are the same number with different coefficients, so they cancel out. For my y's, I have a negative 14y and a positive 14y. Those are also the same coefficient with different signs, so they cancel out, leaving me with 0 on my left side. On my right side, I have a positive 70 and a positive 70. Notice they are the same coefficients, but they're also the same signs. So I have to add them together and get 140. Since I'm out of variables, I ask myself, is this a true statement? And it's not, so I cross out the equal sign. And since it's not a true statement, that means I have no solutions. Alright, we're going to skip number 8 and we're going to go to number 9. On number 9, it says set up a system of equations to solve the story problems and define your variables first. So it says 2 times a number plus 3 times another number equals 13. The sum of the two numbers is 7. What are the numbers? Well, this one is pretty straightforward. They want to know what the numbers are, and we don't know. So we're going to say that x represents my first number, and y is going to represent my second number. Now I can use those two variables to come up with two equations. Let's start with the first sentence again. So it says 2 times a number. Well, I don't know what that number is, so I'm going to let it be my first guy. So I'm going to say 2 times x plus 3 times another number. Well, I'm going to say that's my y. So 3 times y equals 13. Now it says the sum of the two numbers is 7. Now sum means addition, so I want to add the two numbers together and set that equal to 7. Now I have my system of equations, and I need to solve by elimination. So I want to choose a variable here to work with. I think it'd be easier to work with the x's because I can easily turn a 1 into a 2 by multiplying the whole guy by 2. But remember, I want different signs, so let's make that negative. Now when I do that, my top equation doesn't change. I'm going to bring that straight over. 2x plus 3y equals 13. My bottom equation, though, needs to be multiplied by negative 2. So negative 2 times x is negative 2x. Negative 2 times y is negative 2y. And negative 2 times 7 is negative 14. Now, let's add these two equations together. 2x and negative 2x cancel out. 3y and negative 2y give me 1y because 3 minus 2 is 1. And 13 minus 14 gives me a negative 1. So that means my y variable is equal to negative 1. And I'm going to substitute that back into my bottom guy because it looked a lot easier. Now when I do that, I'm going to get x plus negative 1. So I'm going to write that as x minus 1 equals 7. Then I can add 1 to each side, and x equals 8. Now finally, this is a word problem, so we need to write our answer as a nice complete sentence. It doesn't have to be fancy, it just has to be descriptive. If x equals 8, x represented our first number, so we can say the first number is 8, and y was negative 1. Y represented our second number, and our second number is negative 1. Now don't forget, we need capitalization and punctuation, and we should not abbreviate any words. Alright, number 10 is a lot like number 9, so what I'd like you to do is pause the video and try number 10 on your own. Okay, hopefully you let x represent your first number and y represent your second number. Then your two equations should have been 4x minus 2y equals negative 16 and x plus y equals negative 1. When you multiply the second equation by 2 to eliminate the y's, that'll give you a new equation of 2x plus 2y equals negative 2. Add them together and you're left with 6x equals negative 18, so x equals negative 3. I substituted x back into my second equation and got negative 3 plus y equals negative 1, so y equals 2. That means the first number is negative 3 and the second is 2. Alright, on number 11, Tricia and Byron are washing and vacuuming cars to raise money for a class trip. Tricia raised $38 washing 5 cars and vacuuming 4 cars. Byron raised $28 by washing 4 cars and vacuuming 2 cars. Find the amount they charged to wash a car and vacuum a car. Now, for this problem, we're talking about washing cars and vacuuming cars. I think it would be better to use W and V instead of X and Y. So I'm going to let W represent the price of a car wash. And then I'm going to let V represent the price of vacuuming a car. Now, let's come up with two equations. It says Tricia raised $38 washing 5 cars, so that's going to be 5W, and vacuuming 4 cars, so 4V, and she made $38. Byron raised $28 washing 4 cars and vacuuming 2 cars. Now we need to solve this equation, and we're going to do it by elimination. So I look here and I can easily eliminate my v's by multiplying the bottom equation by -2. I can bring my first equation straight over because I didn't mess with it, so 5w plus 4v equals 38. Now let's distribute this -2 in my second equation. -2 times 4 is going to give me -8w. -2 times 2 gives me -4v. And -2 times 28 gives me a -56. Now when I add those together, 5v and -5w and -8w give me -3w. My v's cancel out, and 38 minus 56 will give me a -18. Now I can divide each side by -3, and w is going to be a +6. So I want to take that w equals 6, and I'm going to substitute it back into my bottom equation over here. So I can say 4 times 6 plus 2v equals 28. Well, 4 times 6 is 24. And if I subtract 24 from each side, 2v is going to equal 4, which means v equals 2. Now finally, I need to write my sentence to describe my answers. So w equals 6, that means a car wash is $6. V equals 2, that means vacuuming is $2. So it costs $6 to wash a car and $2 to vacuum it. Let's go to number 12. On number 12 it says, Fire Marshal Bill is caring for injured animals due to a fire he started. He currently only has birds and deer. The animal being cared for have 25 heads and 74 feet. No animals missing a foot. How many of each type of animal are at the station? So we've got birds and deer. I'm going to let B represent the number of birds, and I'm going to let D represent the number of deer. Now this one's a little tricky because they only gave us two numbers, 25 heads and 74 feet. Now if you think about it, each animal is only going to have one head. So that should mean there are 25 animals all together, which means the number of birds plus the number of deer is going to equal 25. Now the feet are a little bit trickier. There's 74 feet, but we have to think about the type of animals that we're working with. He has birds and he has deer. Now birds only have 2 feet and deer have 4 feet. So that means I can say 2 feet per bird plus 4 feet per deer is going to give me a total of 74 feet. Now I can solve this system of equations by multiplying my top guy by -2. So -2b minus 2d equals -50, and bringing my bottom guy straight over. I'll add them together and my birds will cancel out, leaving me with 2 deer. And -50 plus 74 is 24, so that means D equals 12. Now I can take that 12 and substitute it back into one of my original equations, and I'll have B plus 12 equals 25. Subtract 12 from each side, and B equals 13. That means he has 12 deer and 13 birds.